Okay, there we go. Finally got the. Um, can you see? Can everyone see the screen?
Yes.
Yes.
Okay. Um, so he's proposing a diagram for the voting mechanism, uh, which is fairly straightforward to go through, right? So um, he's proposing that there's some registration token to get, which is the handed back, or yeah, handed back along with the rev address, and then given essentially a capability or an authority on some store. So that's his diagram. I was hoping we'd have a different diagram. Here we go. This is the one I was looking for.
That was one I put together. Still trying to figure out how to get the relational encryption included. But
Oh well, so that's very simple. So I guess what I'll do is I'll just draw one on the fly here, so that we can have the content that we actually need.
um,
So hang on.
there are links in Dan's document to an editable copy of the sequence diagram.
It's okay. I've got OmniGraffle here. It'll be fine. All right, and so go to stencils, and so to start with, we just want to talk about how we've hacked into DAPI, right? Not DAPI, Zulip, right? So that's the first thing, and there we go. Okay, there you go. So if a user speaks to Zulip, I'll use. Okay. Come on. Here we go. So here's Zulip. Then what Dan's thing does is add a trigger to the relational database. Oh, I'm missing one gadget. So let me move everything over. Okay, there we go. Move this one over just a little bit. Okay. So this is our target architecture. And I'm just gonna fill in what we've got. So if a user speaks to Zulip, essentially is attempting to talk to another user, right? Then the standard the standard thing is Zulip is the central resource, and so another user sees the modifications to Zulip. And what Dan has done is to place a trigger on the relational store so that it so that the SQL speaks to the chain. So it produces Rolang, a Rolang deploy, which then gets stored on the chain. Let's see, maybe I can do this. So once that happens, we have then the validators are essentially disseminating the information amongst each other. So it's available throughout a shard. So if I go and grab one of these, and so essentially this is where the shard lives, right here. Okay, then what I'd asked Steve Ross Talbot to do was to look at this one where you can go from chain back to the Zulip SQL. And then, well, so if this is a fresh instance of Zulip, then uh, this user can now see the messages that have been uh, put into this instance. And what that does is that federates this off-the-shelf application, right? So we get these basic capabilities with a very, very minimal amount of work. So the two pieces of the puzzle that we get are the Zulip data is now going on chain, and because it's going on chain, you know, it's you don't lose the data, right? So it becomes this immutable record of the conversations. So that becomes a reasonable framework or platform in which to talk about the in which to have governance kinds of conversations. And then in addition, this thing is decentralized. And as a result, Zulip becomes decentralized, because now if the fresh instance picks up the data from chain, right? So essentially what you have to have is an entity that's either alerted by a subscription that a change has happened to an address that's of interest to the Zulip instance, or it has to poll every so often. It has to go and check, let's say, has anything changed on chain? And then once you have that little piece of the puzzle, then it becomes bidirectional, right? So you can flip this around. You can, flip the whole diagram, and a user updating Zulip this way, as long as we have this kind of arrow here, this user, if they're talking through Zulip, that data will make it through to this user. So the idea is that you are able to, with minimal effort, get a decentralized version of the application that has provenance built in, right? So off-the-shelf tools, minimal application of effort, suddenly they become decentralized services, right? And the hope is that that this becomes a design pattern, right? That this is not something that you can that is specific to Zulip. So you can of course apply it to RChat or other things of that ilk, but also to a wider and wider array of applications. So for example, if instead of Zulip we were talking about a map service, then you could take a geolocation service and turn it, such as Google Maps, and apply the same kind of architecture to it, and get a decentralized map service. You could do the same thing with an email program, right? So that instead of a centralized email solution, you now have a decentralized email solution, and so on and so forth. And this becomes interesting and useful once we start thinking about this in the context of disruptive changes, right? So it's not just that we want to upset the apple cart with respect to the economics, although the economics are not so great right now, but rather that we want to prepare for a time when these services might be interrupted due to fairly significant changes. right? And that's what this kind of availability architecture makes possible, right? So, so the essentially what you're doing is you're saying this becomes the availability component, but also it has the knock-on effect of you know, making it so that there's no one central owner of the Zulip service, right? They're all connected, and with a immutable store for the information that's stored. Now, there's one other feature that has to take place, of course, and this is one that, you know, again, we have to kind of work out the mechanics of, but is uh, uh, it's not hard. It's just engineering, and that is that since you're putting messages up on an immutable store, you have to be able to you have to be able to encrypt them if you want any kind of privacy. So what you know, and that's sort of typical for privacy on blockchains. You have to have some kind of mechanism for encryption, and there are lots of ways to achieve that, but that's another feature that sort of is a must-have if you want there to be private communication across a channel, you know, from Alice to Bob that goes through a path like this. All right, so let me stop there and see what if there are any questions or comments about what I've said.
I did have one question. When I sit in on the RChat sessions, I keep hearing about Postgres, and apparently it's a open database. So is RChain replacing that piece? So it's replacing the Postgres, or how does that?
Okay, so let me so essentially what I'll do now is to refine this diagram, and instead of having this be, so notice how we could take this rectangle and treat it as a single, you know, agent, just call it RChain, even though we know that it's an entire shard, right? So the same thing is actually going on with Zulip. So if we were to take Zulip and expand it or explode it a little bit, we'd see that it has many components. And one of those components, so now let's see if I can, one of those components is Postgres. So let's see if I can take all this stuff and move it to the right a little bit. And then grab, so that one. So if I now change this to Postgres, then what's really happening is that inside this Zulip component, right? So this is really this is really the Zulip client, right? And this is the Zulip store, right? Which happens to be Postgres. So what's really going on is that when the Zulip client receives an interaction from the user, say through a browser, right? And the browser could also be depicted as an agent in this diagram, right? But when the Zulip client receives an interaction, then the Zulip client stores pieces of that information on the Zulip store, which is Postgres in this case, right? And then Dan has introduced yet another agent. So if I move everything over here just a little bit, okay. So Dan has introduced another agent. Come on, give me the guides. All right, well, I'll do it that way. That is the trigger, right? So it's a Postgres trigger. And whenever there are certain actions that happen on the Zulip store, the trigger is notified, and as a result, it then takes an action to talk to RChat. Okay, and then this happens after that. All of these happen later in time. All right, does that answer your question, Steve?
Yes, that was helpful. Thank you.
Sure. And then the same thing happens. So what I'm hoping Steve and Dan do together is to do you know, if that's a trigger, then we want to co-trigger, which will go the other way, right?
And our trigger on the other side can be new block added in the RChat.
Could be, but then you'll get lots and lots of times when the trigger is waking up, but doesn't have any Zulip content.
Yeah.
You might want listen for data at name. Right, so
I mean, when to call listen for data at name.
Oh, I see.
Mm.
Okay, yeah. So that's yeah. Essentially, you know, we want that, and then these have to happen after. Right. So this is that architecture, and of course, you know, once you have it going one way, you can get it going the other way. Any other questions about this and what it's useful for? Why we would want to do it?
So we can basically even replace other side with something else. Because now we have the data inside the RChain, which are not really something specific to Zulip, maybe. For example, chat, something, and we can connect on the other side some other chat. And
that's exactly right. That's exactly right. So you could take a diagram like this one, and instead of Zulip, you could have RChat.
Yeah, I mean, maybe we should just call it Zulip or other, and then leave it that way. Maybe that will be generic enough. Or Zulip, RChat, etc.
Yeah. Right. Yeah. I mean, so but I like to be specific so people can get the idea that it could be anything else. Mm-hmm. So that now, of course, the one thing is that in this architecture, we don't have to know anything about the semantics of Zulip messages, right? Just, you know, a trigger is placed on the SQL server. It's like when, you know, your tables are updated, let us know. And then we put all that information, you know, without a lot of consideration on chain. In this architecture, now we have to map a Zulip message and user to a RChat message and user, right? So there's a semantic component that has to be added to the picture. Does that make sense? Like it could be that RChat or Slack or whatever thinks about users and messages differently. It has a different format for messages. It has a different format for users, and those kinds of things. And so the way the tables are structured is different. And so you have to, so if you're going this direction, you have to pick apart the Zulip data and reassemble it in RChat style. And then going this direction, you have to pick apart the RChat data and reassemble it in Zulip style. Does that make sense?
Yeah, I mean, we should probably include that semantic map layer in the in the diagram, because I'm thinking you could basically, the same pattern can occur with accounting systems and ERPs, right? So you're taking or capturing some portion of the accounting data onto the blockchain, and then that might trigger things in different ERP systems. And so in all of that, you need to know the semantic map. It's not necessarily even a one-to-one. It could be one-to-many or whatever.
That's correct. That's correct. So that's why this one is relatively painless. So decentralizing an existing app is relatively painless because all you had to do was to figure out where to place your tap, so to speak. Right? It's like a wiretap. Right? So you place your wiretap, and now you've got a listening device that can forward. Here, you're not just placing a wiretap, right? You're doing something that's much more invasive, which means you have to understand how this works and how this works. Does that make sense?
Yeah.
Yeah.
How do you match the private key with the account in Zulip?
Yeah. So that's something that we will do for RChain governance. Is, I mean, as long as you're just doing this, you don't have to worry about that, right? It's not about private key, or you can put any kind of mapping like that external to Zulip, right? It doesn't have to be inside Zulip. As soon as you start using it for these kinds of applications, for the voting, then you do have to have mapping. And so this is why we've been insisting that people give us a rev address, is because what we'll do is turn around and make a Zulip user using that rev address. So the user won't get a user creation method directly. So we wrapper Zulip with a user creation method. Go ahead.
I was originally thinking to use MetaMask to log into Zulip, but what I did there was I put a DAPI app for the voter registration, which would link the Zulip account to the user, to the rev address.
Yeah. Does that answer your question?
Yeah.
Cool.
So just a better user to make account for himself and someone prove that he has an ownership.
Yes, I understand your concern. Sure, right. So there's going to be different trust burdens in different situations. I mean, right now, because there's the co-op and it's a legal entity, and we've spent some time vetting and validating that organization, then it's got more gravitas than an arbitrary user on the internet. But you're right; it could be the case that the general architecture, you might want to put that burden of proof somewhere else. So and from a decentralization perspective, that has some weight, that carries some weight. So yeah, that's a good point.
For me, this concept is also, I'm looking this as, when I want to read some data, I'm reading always my local observer node. And when I want to write data, I'm searching for some external node, like a validator, where I can push my deploy.
Yes, that's correct.
Which gives like additional security, or my data. My data is always local to me when I want to read, and the R node is taking care of all of the synchronization. And for me, this is like a very big thing, because now we need to do it, all of these things ourselves, and in different way with different database. And this is like a universal way when we have a programmable general purpose database, which is distributed. So
yes, agreed, 100%. Yeah, that's a very good point. For me, the thing that I like about it is just this diagram alone speaks volumes, right? Because you can this becomes a template that you can use to do what we've been saying you could do, which is to decentralize a bunch of different services, and that is the name of the game, right? That is our goal and our aim. There's the concern for these centralized services goes all the way to the U.S. Congress, the European Union. All of these states, as well as the markets, are worried and concerned about the centralization of online services. And what this provides, this infrastructure provides, is a mechanism whereby these online services are decentralized. So that at least the tech part of it, the tech part of it, and to a large extent the economic part of it, is now reasonably decentralized. So the one thing that is very interesting, or there are many things that are interesting about these questions, but a question that Steve Ross Talbot took up in our last RChat call, which I think is really important to answer, is who will see this value proposition in such a way that they want it funded. Now, obviously, if you put this architecture inside an enterprise, it just works, right? An architecture very similar to this, but without the same kinds of trust boundaries, is what you find inside Google and inside Amazon, right? They have a bunch of Google nodes that give you, one of the world's fastest databases, right? And so if you replace this with Gmail, right, and the browser clients, something like that is going on. But they don't have to worry about one Google node not trusting another Google node, right? And what RChain has done is to include that piece where you don't have a trust relationship between these nodes. But it's a similar kind of architecture inside the enterprise. It's just that now you can take the architecture outside of the enterprise. So the extent to which it would improve upon existing enterprise infrastructure, you could potentially sell it to an enterprise, right, for use internally. So that's one method, but it's going to be at least a decade before this kind of architecture competes with what you find inside these behemoths like Google or Amazon, or because they've had decades to build these super large, super fast compute infrastructure. So it's going to so you have to look at other value add propositions, and that generally has to do with crossing certain kinds of trust boundaries, right? So if so for example, what I've talked about before is if this is one enterprise region. So if this is, say, US and this is Europe, for example, or even just this is UK and this is continental Europe, then it has value because typically folks in this region don't trust folks in this region. So the quote unquote trustless mechanism has value for that situation. Does that make sense? Do people understand what I'm driving at here when I'm talking about who's going to see the value prop?
Yes, it's helpful.
It crossed my mind that just storing the packages for like NPM or Cabal, we need to trust the source. And
oh yes, that's why they're
these
signed.
services are decentralized. Yeah, so this is like a perfect fit.
Yeah, that's correct. That's exactly right. That's exactly why they're signed, right? And then even the fact that they're signed doesn't really help very much, because you could still have malicious stuff inside there, and it could be signed by a sock puppet, right?
Yeah, and then how can I check who changed in the? I don't have any history, right? How can I check this? So
Yeah, exactly. So I mean, I guess what I would do is I'd love to put out the question to the community, to the hive mind. Um, what do you think are entities that can recognize early on the value proposition, right? Like we recognize the value proposition, but that's because we're looking at the world very differently, right? We're saying, the Googles and the Amazons and the Facebooks of the world are, having them control these online services is economically dangerous and dangerous from a societal point of view. And at the same time, providing a decentralized mechanism makes it possible for people on the ground to self-organize and build up services, because they don't have to establish the same kinds of trust relationships. They can make connections that have higher bandwidth, because much of what was in the the building of the Google brand or the building of the Facebook brand no longer needs to be there, because you have the trust mechanism here, right, in the chain. But that's a radical point of view. That's a the libertarians and the anarchists can see the value in that point of view. And to some extent, those have been the kind of people that have funded the blockchain. But as we begin to look out into the future and we want to attract a different community of investors, what are some of uh, other narratives around the value proposition, right? That's sort of the idea. I mean, at the end goal is a global computer where you have a lot more capability without having to have all of the centralized control and having to and the corresponding debt with respect to organizational trust. So that's the end goal, and I think many people can see that, why that would be valuable. But we have to get there in stages where people can see the value proposition. Like, here's a clear application, a clear, it could be viewed as a value prop. So like the Zulip community, they get to be federated with minimal effort, right? The effort to federate Zulip servers is now minimal, right? So they can see that might be of value. But if we throw it out to the hive mind and say, hey, hive mind, what are some other value propositions for this kind of architecture that people can recognize? I think that might be of use. Does that make sense? That question?
Yeah.
So Steve, your transport and logistics folks, what are they thinking? And
Yeah. So the wheel is turning in my head as far as what would be low-hanging fruit, so to speak, that we could go after. And I don't have, I still need to kind of think through it and think what the possibilities are. So hopefully I'll come up with something, but right now, I'm still kind of working through it.
Yeah, understood. Yeah, not to worry.
So from the perspective of implementation, it would be useful that we have some kind of mapping between relational data that we usually have to RChain, to rolling in a way that is like straightforward. So if you have some schema, it's not a problem. You can just generate some rolling code from this schema.
Yeah, so Dan has sort of a prototype of that where so a lot of applications like Zulip use frameworks like Zulip is using oh god, what's the name of the orange Django. So Zulip is using Django, and so and that's because again, if you look inside Zulip itself, right, the client is all object and store is all relational. So you have to mediate between the two via some object relational model, right? And that's what Django is doing. And so as long as you stay inside the image of object in relational, the mapping to the key value is very straightforward. In fact, that's one of the reasons that key value exists, is because the mapping of object to key value is so easy. So it becomes it's an easier fit. So as long as you stay inside that, the mapping is very straightforward, and that's what Dan has exploited, right? If you want to widen that out, then that's a bigger picture. But I think we can get a lot of bang for buck just on, looking at the object relational stuff for some period of time, and then there is a mapping. It's not hard to do relational stuff.
I see. Makes sense.
Yeah. Cool. Awesome. Well, I really appreciate your time. Next week we will talk about biosimulation, and we can have some fun that way.
I have a quick question for you.
What's that?
There's been a lot of interest in hardware to do row line in the education and app developer group. People want to talk about it.
Yeah.
I've been looking at the associative memory hardware, in-memory computing devices, models.
Yeah.
Is that where we should be looking?
I would say the sky's the limit. I have a couple of different architectures that I looked at. A lot of those architectures were really driven by what our platforms were. I mean, in terms of what you can put together with a few bucks, a field programmable gate array is kind of, there's a lot of support. There's a lot of gadgets and tooling for FPGAs. And so you can easily take an existing higher level design language and render it out to FPGA. And there are a lot, so for example, for those of us who are, who find Haskell or functional programming in general to be expressive and a good thing. There are lots of packages out there that allow you to express a hardware design in a functional setting, and then render that out to something that can run on an FPGA. So that's the tool chain that Gabi and I used a couple of years ago. And it's the same tool chain that Satnam Singh and Jan Gray and Alan Brown and I used inside Microsoft over a decade ago. So yeah, or about a decade ago.
Thanks.
Yeah, sure.
And on that same note regarding open source hardware, I was thinking, in the future, the ultimate is to have consensus on a chip, a consensus chip. But in order to get there, or at least, we talked several weeks back about equational reasoning, for Casper. But a first step would be doing equational reasoning for bisimulation. So the thought is, so if next week, if we're talking about bisimulation, perhaps there could be a tailored part of the discussion as far as what would be discussion on a equational reasoning for bisimulation, with the ultimate end of getting to an equational reasoning for consensus. But equational reasoning for bisimulation in the idea of would that be a good baby step towards creating a circuit, a logic circuit for a chip, if that's a possibility.
Well, remember, bisimulation is much bigger than consensus, right? Consensus is a very specific question, and bisimulation concerns the equivalence of processes in general.
Okay. So I guess I was going back to when the goal was to have the equational reasoning for consensus.
Yeah, right.
I thought I thought that was sort of the big project, and a smaller effort would be equational reasoning for bisimulation. But when I'm hearing it's actually reversed.
Yeah, it's just that with bisimulation, we know exactly what you need, right? You need a congruence, and we know the conditions that whereby we can get a congruence for. This is a lot of stuff to talk about. It's 8 o'clock. Got to go to the stand up, but we can talk about that next time.
Okay, great. Thank you, Greg.
Thank you.
Presentation today.
Appreciate it. Thanks.
Bye-bye.